Hello, and welcome to a special lecture presented by www.free-academy.com. In this lecture, we're going to be covering the derivatives of logs and exponentials. Now, this is going to include log of any base, and then the special case, the natural logarithm of a function. Then we're also going to cover a constant raised to the power x, which is kind of like an inverse for a polynomial almost, and then the special case of e raised to power of x, or function, or anything like that nature. And I want to point out that these are actually special cases of the ones above them. They're simpler and they come up a lot more, but we're going to learn them all just to be very, very rigorous. Now, without wasting any time, the derivative of log base b of a function u is going to equal u prime over u ln of b. If for example, u just equals x, the derivative of x is 1 over x ln b, but it could also be x squared, which would be 2x squared, so on and so forth. I'm not going to go very deep into doing examples, because at this point you should really get what u and x and all that kind of stuff stands for. But either way, whatever your function is that you're taking the logarithm of, you take the derivative of it, you divide it by the original, and multiply it by natural log of b. Now, in the special case where you have ln of u, you're going to get u prime over u. These are very, very, very simple derivatives. So the derivative of ln of x would equal 1 over x. Very simple case there. And the reason for this is, using this formula for the original log, you would get the ln of e, which equals 1, which is why it simplifies to what you have there. Now, before I give you the answer of what the derivative of a constant raised to the power of x is, I'm actually going to derive it. So we have an equation, y equals b to the x. And we're going to take the logarithm of both sides to solve this. It's going to give us the ln of b, sorry, just making a bit of a mistake there. Log base b of y equals x. Alright, now that we have this part, we're going to use implicit differentiation to find find our derivative here. So this is going to give us 1 on this side, and this will give us 1 over y ln b dy dx. And that's just using our formula right up here. Moving forward with this, now we're going to actually solve for y. We're going to cross multiply to get dy dx equals the y times the ln of b. Now we have an equation for y, which is what we originally started with, so we'll substitute for it, and we get the derivative equals b to the x ln b, which is our answer here. Now, by the same logic as these two examples, if we use exponential, or e as our base, the ln of e equals 1. So that gives us a much, much more simplified situation. And without going through the rigor of deriving everything, the derivative of e to any power is going to equal u prime e to the u. So the case of e to the x, your derivative is e to the x. I'm actually going to write that out to show it to you guys. You're going to love doing these. They're just so easy. The derivative of e to the x squared equals 2x e to the x, because you just take whatever your u is, take the derivative of it, and multiply it by the original. They're so easy, and sometimes they can actually be fun. Not that they're ever really fun, but when you compare it to how difficult some of your other derivatives are, we're going to enjoy it when you see these. So that's all we're going to cover for this lecture. We'll do some more practice problems if you guys want to check that out.